Hello, good day everyone. So let us have another topic for your hydraulics and that would be buoyancy. So ano ba yung ibig sabihin ng buoyancy? No, yan yung pag-uusapan natin ngayong araw na ito. So for example, no, say that we have a holding an object sa kamay natin and if we try to submerge that one into a fluid or sa tubig man lang, di ba, we will try to notice that your object feels lighter. Like for example na lang, no, ikaw, magbibitbit ka. Kunyari, ikaw, specific person ka. Okay, ikaw, nagdadala ka ng isang galong tubig. Okay, it is heavy kasi isang galong tubig yan. No, isang galong tubig. Nung dinala natin to sa tubig, no, sa tubig at sinubmerge natin to sa tubig, di ba parang it feels like 1 gallon of water feels like lighter, no? And that brings up to the concept of buoyancy. Ibig sabihin, kaya pala gumagaan yung mga kinikerry natin or binibitbit natin na mabibigat na bagay kapag sinasubmerge natin siya sa tubig, most commonly sa dagat or sa pool, no, mas nagiging magaan siya. It is because of the buoyancy. So, kung nakatry kayo swimming with your friends, no, outing with your friends, yung kapag inaabaw or sinasabak niyo sila or ano ba, binubuhat niyo sila, di ba they are lighter kapag nasa dagat or nakasubmerge kayo sa tubig. And that is because, no, tinutulungan kayong i-carry ng buoyancy yung weight ng dinadala ninyo. So for example na lang, we have here an object that is being submerged in a fluid. So sabi natin, kapag sobrang sinubmerge natin yung ating fluid, yung pressure natin is mas malaki. Bakit? Sabi di ba natin that pressure is equals to gamma H. The deeper the object goes or the deeper na pinupuntahan natin, mas lumalaki yung amount of pressure. Okay? And because of that, no, because of that increase in pressure, nagkakaroon tayo ng force upward, no? Force upward, where yun na nga, it's because of your buoyancy, no? Because ano ba yung buoyancy? Okay? Buoyancy is also known as your buoyant force. Okay? It is the type of force na ini-exert natin or ini-exert sa object when your object is whole or partly submerged. Okay? So, ibig sabihin, if your body or an object is hindi naman siya nakasubmerge, ibig sabihin, hindi magkakaroon ng buoyant force. Okay? I hope I'm making sense. Ha? So, by definition, okay, you have here your Archimedes principle. It states that, what is your buoyancy? Sabi nga dito, a buoyancy is an immersed body which completely or partially submerged in a fluid that is buoyed upward by a force equal to the weight of the fluid displaced. Ibig sabihin pala, the self-weight of the body is equals to your buoyant force. Okay? So take note that buoyant force is a vector quantity and not a scalar quantity. Ibig sabihin, the direction of your buoyant force is always upward. Okay? And it is, ano nga yan, and it is opposite to the direction of your weight. Kaya kung napapansin niyo, 'di ba kapag tatalon kayo sa dagat na lang, kapag tumalon kayo sa dagat, 'di ba parang lumulutang kayo agad, pinupush kayo agad pataas sa surface. That is because of the buoyant force or the buoyancy. So kung maliligo kayo sa dagat, tapos kayo ay lumulutang doon, sabihin niyo agad, that is because of buoyancy. No? Because your force or your buoyant force is equal to the weight of the fluid that is displaced. Pag sinabi natin displaced, that is the volume or that is the part of your body that is being submerged. Okay? So buoyant force, it is the upward force exerted with a fluid and consequence of a pressure increasing with depth. Yun yung sabi ko kanina, no? If your body is being submerged into a specific height, no? Ibig sabihin, that is gamma H. Kasi iba naman yung pressure natin in a specific height. No? The deeper it is, the bigger the pressure it has. Okay? So you have the floating body or your flotation. Now, for example, this is your object and your object is being submerged in a fluid. where this one is your liquid surface. Okay, ibig sabihin, part ng object mo is nakasubmerge into a fluid. So, this one, tatawagin natin to as your volume displaced. Ibig sabihin ng volume displaced is the part of the object that is being submerged into a fluid. Okay, tatawagin naman natin yung VE. VE stands for a part of their object that is not being submerged. Yung hindi nakaloobog. Okay, but if your object is fully or wholly submerged, ibig sabihin wala tayong kinukonsider na VE. Lahat yon VD or volume displaced. This is your buoyant force, no? Your buoyant force formula is unit weight of the fluid times the volume of the draft. Okay? And this one will be the weight of your air, where the unit weight of, the weight of the air is unit weight density times the volume. No? We all know that the unit weight is equals to weight over volume. So, derive natin to, weight is equals to unit weight density times the volume. So, kung kagamitin natin yung inyong to satisfy the equilibrium, no? As you can see here, we can see that weight is just equals to the buoyant force. No? And it is also stated to Archimedes' principle that the force is equal to the weight of the fluid displaced. Okay, so makes sense. Weight is equals to the buoyant force, where the formula of your buoyant force is unit weight of the fluid multiplied by the volume displaced, okay, or the volume or part of your object that is being submerged. Okay, so therefore, having that said, no, weight is equals to buoyant force, and that would be the initial unit weight density times the volume is equals to the unit weight of the fluid times the unit weight of the draft. Okay, so what if naman your body is totally submerged? Ibig sabihin, wala na tayong volume that is not being submerged kasi nga, totally, no, lahat yung body natin is nakasubmerged na. Ibig sabihin, lahat ng part ng object natin is considered as a volume draft, which is your variable VD. So you have the weight of the air. Weight of the air is equivalent to your buoyant force plus the weight of your water. Okay? Makes sense naman yan, no? Kasi pinupush rin ng tubig yung ating object. So, volume displaced is equal to your volume initial. No? So, buoyant force is equal to the unit weight of the fluid times the volume initial. So, what would be the weight of the water? Okay? So, kung gagawin pa natin tong to satisfy the equilibrium, no? Using your summation forces vertical is equal to 0, taking upward as positive. So, you have weight of the water plus your buoyant force minus your weight of the air equals to 0. Lipat natin yung dalawa on the other side of the equation. Therefore, the weight of the water will be equivalent to the weight of the air minus the buoyant force. I hope, no, nakilala lang nyo na sino yung buoyancy at ano yung buoyant force, no? So, therefore, no, your buoyant force is also equal to the weight of the air minus the weight of water. So, let us try to have an example, no? This is just a recap, no, or testing your knowledge during your physics, because I believe during the physics, no, the buoyancy is already discussed, no, but sige lang, no? Let us try to recall this one once again. Okay, so for example, you have a stone that weighs 460 Newton in air. When it is submerged in water, it weighs 300 Newton. So do you get the concept? No? Nung meron ka daw bato, no? I-explain ko muna yung nangyari. Nung meron ka daw bato, sa air pa lang, it weighs 460 Newton. Okay? But then, nung sinubmerge mo daw yung bato into water, yung 360 naging, yung 460 Newton, naging 300 Newton na lang. Bakit? It's because yung weight niya is nabawasan dahil merong tumutulak sa kanya pataas, and that is your buoyant force. Ibig sabihin, parang gumagaan yung object kapag sinasubmerge natin siya or nilulubog natin siya sa tubig. Okay, sana nag-make sense na yun. First is that, find the buoyant force exerted by the water on the stone, find the total volume of the stone, and find the weight of the density of the stone, and find the specific gravity of the stone. Madami agad tinanong. No? So, for example, this is the liquid surface. Ito yung stone natin. First question is to find the buoyant force exerted by the water on the stone. So, buoyant force yung tinatawag. So, ay yung hinahanap. So, na-derive natin yung formula kanina that buoyant force is equal to the weight of the air minus the weight of water. So, that is just 460 minus 300 Newton. And that would be equivalent to 160 Newton. Okay? So, next is that let us try to find the total volume of the stone. Okay? So, we know that the formula, no, kapag completely submerged na siya, no, kapag completely submerged, your volume displaced is equals to your volume initial. No, magkapareha lang yan. Multiplied by the unit weight of the fluid. Since our fluid is water, no, so therefore, yung ating unit weight density, that would be 9.81. No, ito yung kilala nyo. Your unit weight density of water is 9.81 kilonewton cubic meter. But since the weight is in Newton, so i-convert natin to in Newton. Multiplyan lang natin to ng 1,000. Kaya kung nakikita nyo, you have 9,810 Newton. Okay, so Newton here will be cancelled. So it will give the volume of the stone as 0.016 cubic meters. Next is to try to find the weight density of the volume. Weight density of the volume. I'm sorry for that. The weight density of the stone. Weight density yung hinahanap. Ano ba yung formula ng weight density? Diba, that is just unit weight density times weight over the volume. Ang hinahanap lang natin ngayon will be the weight density. And that would be equal to 460 Newton divided by 0.016 cubic meters. Ito yung volume na nakuha natin a while ago. Therefore, the unit weight density would be equivalent to 28,750 Newton per cubic meter. Okay, so how about the specific gravity? So dito, marirecap yung mga natutunan nyo during the fluid properties. No? Kasi babalikan natin yung mga formulas ninyo dyan. So stating that, the formula for your specific gravity, that is the unit weight of the fluid divided by the unit weight of water. So this is something that you already know, no, during the prelims natin. So since specific gravity is unitless, therefore Newton per cubic meter will be cancelled. Okay? So using your calculator, can you check if the value is equivalent to 2.931 kasi nga unitless yung specific gravity natin. Okay? To continue, let us have another example. So a cube in an edge of 0.2 meters and a specific gravity of 0.8 is floating in water. Question, what is the volume that is submerged in water? What is the volume of the cube that is exposed in the air? So kung babasahin natin yung problem, no? What is the volume that is submerged in water at hinahanap din yung volume na exposed sa air? So kung tayo gagamitin natin yung critical analysis natin or critical thinking natin into a problem, no, mai-imagine natin na, yung cube pala, hindi pala siya fully submerged. No, bakit ko ba nasabi na hindi ito fully submerged? Kasi hinahanap yung submerged part, hinahanap din yung exposed sa air na part. So basically, hindi pala completely submerged yung ating body. So, ibig sabihin, kinakailangan yung paaralin yung inyong or paganahin yung imagination natin sa problem. So this is a state, no? So dito, assumption ko lang to, or let us try to assume that the liquid surface is nandito. Kasi hindi man natin alam yung complete height of the draft natin or yung complete height ng pag-submerge ng ating cube. Alam na natin, partially, it is submerged. Okay? So, this is the part na tatawagin natin to as your volume displaced, and this is the volume of a cube that is exposed in the air. Solution. So, you have weight in the air and you have your buoyant force. Okay. So, sabi natin, buoyant force is equals to the weight. Okay, sundin ko na lang itong nakasulat dito. Okay? So, sabi natin dito, weight is equals to buoyant force, where your weight is unit weight density initial times the volume initial. Okay? Or the volume that is exposed in the air. Okay? Where your buoyancy or your buoyant force is your unit weight of the fluid multiplied by the volume of the draft only. Okay? So let us try to derive the formula, no? So you will have here times the unit weight or times the specific gravity. Okay? Kasi it is being stated man or it is stated in the problem that your unit weight, I mean, ano ba? I'm sorry for that. That your specific gravity is 0.8. Okay? So that is 0.8 times 9.81 times 0.2 cubic meters. Okay? Ito yung sa body ninyo or yung sa object, no? Yun na lang, yung sa object na lang para mas madali. Ito yung volume ng object natin. That is 9.81, 0.2 cubic meters. So since cube man ito, that is understandable na x raised to 3 lang. Okay? So for the volume of your draft, no, that is just 9.81 times VD. Ma'am, hindi ba natin multiply yan ng 0.8 ito dito? No. Okay? It's because it is being specified that your object only, yung object nyo lang yung 0.8 na specific gravity, na may specific gravity. While yung object niyo is nakalubog sa tubig. Okay? Ano ba yung specific gravity ng water? That is 1. Okay, sana na-gets yan. And to calculate that one, no, your volume of the draft is 0.0064 cubic meters. Okay, so question, what would be the volume of the cube exposed in the air? So, makukuha natin, di ba? Makukuha natin tong volume of the object and that would be equivalent to 0.2 cubic meters minus 0.0064 cubic meters. Yan yung nakuha natin a while ago. Therefore, the volume of the cube that is being exposed in the air is 0.0016 cubic meters. It's very easy lang, no? Kailangan nyo lang pagganahin or pag-aralan yung imagination niyo when it comes to the problem. And I think that would be all for our buoyancy topic. Thank you.